Now let's create a function create block, which will take arguments as self, proof and previous hash. Let's define the function what it does. So first we'll make a dictionary, name it block, that we will define each block in the blockchain with its 4 essential keys. These 4 essential keys are first index of the block, then timestamp that represents the exact time when the block was mined, third proof of the block which is the proof that was found while mining the block, and the fourth previous hash. Now let's define the value for each of these keys. For index we will have length of chain plus 1, as the index of new block will be an increment to the previous block. Then for timestamp we will use datetime library to get the exact time when the block was mined. So we will write datetime.datetime.now function which will return the time, and we need to put this in string. Now for proof we will get the proof value from the argument, and similarly for previous hash we will get the value from the argument. For now we will define only these 4 keys. Later on we will add more as per the need. Now since we have a block, we need to append it to the chain, and we know chain is the list, so we can simply append by calling append function and pass the block as argument that we have just created. Finally return the block. Next we will create a function that helps to get details of the previous block, def get previous block, and it take argument self. This function will return self.chain and the last index of the chain list, which we will get from -1. Alright, so next what we will do is create a function that gives the proof which was passed as argument in the create block function. So first, what is exactly proof of work? Proof of work is the thing that miners need to find in order to mine a new block. If you remember from the course, the miners keep iterating the nonce value until they find a valid hash that lies below the target. So here we will define a problem and the miners need to solve them. To solve the problem, miners need to find a proof, which will be a number in our case, and that will be the proof of work. We will define problem that will be challenging to solve but easier to verify, which is the principal point about the proof of work consensus mechanism. So let's define the function proof of work. It will take 2 arguments, first self and second previous proof, which the miner need to consider to find a new proof. We will start by introducing the new proof and initialize it as 1. Why do we initialize this as 1? Because to solve the problem we are going to increment this new proof variable by 1 at each iteration of while loop until we get the right proof. Then we will introduce check proof variable of boolean that will check if the new proof is right or wrong. Initially we initialize it as false. Once the right value of new proof is found, we will assign the check proof as true and stop the while loop. Speaking of the while loop, that is what we are gonna define now. While condition of while loop will be check proof is false. If so, then we will increment the new proof until we find the right value that solves the problem. So we need to define the problem to be solved here before incrementing new proof value. So this is where we use SHA-256 cryptographic hash function. For that, let's define a new variable hash operation, and from hash lib SHA-256 cryptographic hash function. And in this argument we input the operation of previous proof and new proof. And note that this operation cannot be symmetric. For example, if we input new proof plus previous proof, here new proof plus previous proof is equal to the previous proof plus new proof. When we increment new proof, then the previous proof will be older new proof, so this operation is symmetrical. To make it non-symmetrical, we can simply write new proof minus previous proof, because new proof minus previous proof is not equal to previous proof minus new proof. So it works, but this is very simple. Let's make it a little challenging. I will square both of them. So now the operation is square of new proof minus square of previous proof. You may define your own problem here to make it challenging, but note that it must be non-symmetrical. Now to make this acceptable, we need it in right format that is expected by this SHA-256 function. First we need to put this operation in the string, and then we need to encode this string in the right format using the encode function. You can see this example. If previous proof is 2 and new proof is 3, then square of new proof minus square of previous proof will be equal to 5. Then we put it into a string. Now we encode this string, output will be b-5-, which is right format, so that's SHA-256 accept it. And now to get this string only in hexadecimal digit, we will add .hexdigest function. If you go back to the previous example, this is what we get. Alright, so this is our hash operation. Next we will check if the first 4 characters of these hash operations are 4 zeros. And this is the part of mining difficulty. If you remember from the course, miners keep iterating the nonce value until they get the hash value below the target. This is the concept we are applying here. So we will check if the first 4 character of this hash operations are 4 zeros. If not, then we will increment the new proof value, and if it is true, then we will make check proof as true, and the value of new proof will be our proof of work. Let's implement this. Alright, so now let's return the new proof value. So this ends our proof of work function.